Hello friends, welcome back to the channel. Today we are going to understand one of the most important ideas in modern AI, something called RAG. You may have heard this word thrown around a lot. RAG this, RAG that, Retrieval-Augmented Generation. It sounds heavy, it sounds technical, but I promise you by the end of this video, you will explain RAG to your friends using nothing but a simple school example. Here is the one picture I want you to hold in your mind for the whole video. A student sitting for an exam. Sometimes the exam is closed book. A student can only use what is inside their head. And sometimes the exam is open book. The student is allowed to bring the textbook and look things up. That single difference, closed book versus open book, is the entire idea behind RAG. Let me show you. Closed book versus open book. Let us set the scene properly. Imagine a student named Ravi. Ravi has studied hard all year. He has read many books and a lot of it is stored in his memory. Now the exam day comes. In a closed book exam, Ravi walks in with nothing. Whatever he remembers, he writes. If he studied that chapter well, great. He answers correctly. But if the question is about some tiny detail he forgot or something he never studied, Ravi is in trouble, right? And here is the human thing. Many students, instead of writing I don't know, will write something that sounds confident. They guess. Sometimes the guess is wrong, but it is written so neatly that it looks correct. In an open book exam, everything changes. Ravi walks in and he is allowed to bring the textbook. Now, when a hard question comes, Ravi does not guess. He opens the book, flips to the right page, reads the exact paragraph, and writes his answer based on what the book actually says. Important point. In both cases, Ravi is the same smart student. His brain did not change. The only thing that changed is in the open book exam, we gave him access to reliable reference at the moment he needed it. Now replace Ravi with an AI model, and you have understood the heart of RAG. A plain AI is a closed book student. RAG turns it into an open book student. What is LLM memory? Let us slow down and talk about the AI's brain. The kind of AI we are talking about, ChatGPT, Claude, Gemini, and so on, is called an LLM, a large language model. Think of it as our student Ravi. Before the exam, Ravi studied. In the same way, an LLM was trained on a huge amount of text from the internet, books, articles, a massive amount of reading. During training, patterns from all that reading get baked into the model. That baked in knowledge is the LLM's memory. But here is the catch, and this is very important. This memory has three limits, exactly like a student. First, it is frozen in time. Ravi studied until, let's say, last March. Anything that happened after that, he simply doesn't know. An LLM is the same. It has a training cutoff date. Ask it about something that happened after that, and it has no idea. Second, it is general, not specific to you. Ravi read the standard textbooks, but he has never seen your company's internal documents, your private notes, your latest project files. That information was never part of his studies. Third, it is fuzzy. Even for things Ravi did study, he may remember the general idea but forget the exact number, the exact date, the exact wording. So the LLM's memory is powerful, but it is frozen, general, and fuzzy. Hold on to that because it explains the next problem. Why hallucinations happen? Now we come to a word you will hear a lot, hallucination. When people say an AI hallucinated, they simply mean the AI gave an answer that sounds confident and fluent, but is actually made up or wrong. Why does this happen? Go back to our closed book student. Ravi gets a question. He searches his memory, but this particular detail he doesn't really know it. Now, an LLM is built to always produce a smooth, complete, confident sounding answer. It doesn't naturally like to say, I don't know. So, just like a student who doesn't want to leave the answer blank, it fills the gap with the most likely sounding words. The result is an answer that is grammatically perfect, sounds very sure of itself, and is completely wrong. That is a hallucination. Important point. The AI is not lying on purpose. It genuinely doesn't have a way to check itself. It is guessing under pressure, exactly like a student in a closed book exam who doesn't want an empty page. So now we have the core problem clearly. The AI's memory is frozen, general, and fuzzy, and when it hits a gap, it guesses confidently. How do we fix a student who guesses? Simple. We stop making them do a closed book exam. Why RAG was invented? And that is exactly why RAG was invented. RAG stands for Retrieval-Augmented Generation. Let us decode that phrase using Ravi. Generation is the AI writing the answer. That is Ravi answering. Retrieval is looking things up. Ravi opening the book and finding the right page. Augmented just means boosted or helped. Ravi's answer is now boosted by the book. So retrieval augmented generation literally means the AI writes its answer after first looking up a reliable reference. It is a closed book student turned into an open book student. Now think about what this fixes one by one. Frozen memory, solved. We can put fresh, up to date pages on the desk. Not specific to you, solved. We can hand it your company document, your notes. Fuzzy on details, solved. The exact number is right there on the open page. No need to remember it. Confident guessing, reduced a lot. When the answer is sitting on the desk, there is a far less reason to guess. That is why almost every serious AI product you see today, customer support bots, document assistants, coding helpers, is built on RAG. They are all open book students. So the big question becomes, how do we build this open book system? How does the AI actually find the right page out of thousands of pages in a fraction of a second? That is the machinery of RAG, and we will now walk through it step by step. The RAG pipeline. Before the details, let me give you the whole journey in one line so you never get lost. You ask a question, the question is turned into a special number form called an embedding. That embedding is used to search a vector database, a smart library. The search retrieves the few most relevant pages. Those pages become the context. The context plus your question are packed together into a prompt. That prompt is handed to the LLM and the LLM writes the final answer. Okay. Question to embedding, embedding to vector DB, vector DB to retrieval, retrieval to context, context to prompt, and then LLM, and then you get the answer. That is the entire pipeline. Every fancy RAG system in the world is just this chain. For the rest of the video, we will zoom into each box one at a time, always coming back to Ravi and his open book exam. Let us start with the straight sounding one, embeddings. Embeddings. This is the box that scares beginners the most. So let us make it very simple. Here is the problem embeddings solve. In our open book exam, Ravi needs to find the right page. How does he search? If he only searched for exact words, he would fail often. Imagine the question uses the word car, but the textbook's chapter uses the word automobile. Same meaning, different word. A plain word match would miss it. We don't want to match words. We want to match meaning. An embedding is a way to turn any piece of text, a question, a sentence, a paragraph, into a list of numbers that captures its meaning. Think of it like this. Every sentence is given a set of map coordinates for meaning. Sentences that mean similar things get coordinates that are close together on the map. Car and automobile land right next to each other. Car and banana land very far apart. A simpler picture. Imagine a giant library where books are not arranged alphabetically, but by topic and meaning. All the cooking books sit together in one corner, all the space books sit together in another corner. Embeddings are what give every paragraph its location by meaning. Important point. You do not calculate these numbers by hand. A special small model called an embedding model does it automatically for every paragraph in your documents. And also for the question you ask, now everything, your documents and your question lives on the same meaning map. And once things are on the map, finding the nearest neighbors becomes easy, which is exactly what the next box does. Vector database. So now we have turned every paragraph of our textbook into meaning coordinates. Where do we keep all of them? In a vector database. A vector is just the technical word for that list of meaning numbers we created. So a vector database is simply a special storage system that holds all these meaning coordinates and is extremely good at one job, finding the closest ones fast. Come back to the library picture. A normal bookshelf is organized alphabetically, useful only if you already know the exact title. But our vector database is a magical library organized by meaning. You walk in, describe the idea you are looking for, and the library instantly points you to the shelf where all the related pages live, even if none of them use your exact words. Think of it as the difference between a plain index and a brilliant librarian. The plain index only matches exact words. The brilliant librarian understands what you mean and walks you straight to the right shelf. In the real world, these vector databases have names. You may hear FAISS, FICE, Chroma, Pinecone, and others. But do not get stuck on names. For our purposes, a vector database is just the meaning organized library that stores all your pages and can find related ones in an instant. Now the library is ready. A question walks in. What happens next? Retrieval. Retrieval. It is the actual act of looking things up. This is Ravi opening the book and flipping to the right pages. Here is the step by step, and notice how previous boxes click together. 1. You ask your question. 2. The question is turned into an embedding, its meaning coordinates, using the same embedding model as before. 3. That question embedding is taken to the vector database and the database compares it against all the stored page embeddings. It returns the handful of pages whose meaning sits closest to your question, usually the top 3 or top 5. That's retrieval. Out of maybe 10,000 pages, the system quietly picked the three that actually matter. And in a fraction of a second, based on meaning and not just keywords. Important points. Retrieval does not answer your question. It does not think. It only fetches. It is the librarian putting the three most relevant pages on your desk. Reading them and writing the answer is still someone else's job, which brings us to what exactly is now sitting on the desk: the context. Context. After retrieval, we have a small stack of the most relevant pages. That stack placed right next to the question is the context. Okay. In the open book exam, context is literally the open pages on Ravi's desk while he writes, not the whole textbook. He does not need all 600 pages, just the 2 or 3 pages that answer this question. Open and ready. This is the most underappreciated idea in RAG. So let me stress it. The magic of RAG is not that the AI suddenly became smarter. The magic is that at the exact moment of answering, the correct information is placed right in front of it. The AI no longer has to dig through fuzzy memory. The facts are on the desk. Good context has two qualities. It should be relevant, actually about the question, and it should be focused, just enough. Not a mountain of unrelated pages. A student with the right 2 pages open will do better than a student who dumped the entire library onto the desk in a panic. So now the desk has two things on it: the question and the relevant pages. Okay, the next step is to hand this to the AI in a clear way. That handover is called prompt. Prompt. A prompt is simply the full set of instructions we give the AI. The question plus the reference pages plus a clear instruction on how to use them. Think of the prompt as the exact wording of the exam paper we hand to Ravi. A well-designed RAG prompt basically says three things. Here is the question the user asked. Here are the reference pages we looked up for you. Please answer the question using these pages. If the pages do not contain the answers, say so honestly. That last instruction is the quiet hero. It is us telling the student, do not guess from memory, base your answer on what is actually on the desk. And if it is not there, it is okay to say you don't know. This single instruction is a big reason RAG answers hallucinate far less. So the prompt neatly bundles everything: question, context, and rules into one clear package and hands it over. Now, finally, the student writes. The LLM answer. The last box. The LLM now reads the prompt. It sees the question. It sees the relevant pages sitting right there, and it sees the instruction to answer from those pages. And now it does what it was always good at: writing a clear, fluent, well structured answer. Except this time it is grounded in real reference material instead of fuzzy memory. This is Ravi in the open book exam finally putting pen to paper. Same smart student as before, but now every sentence he writes is backed by the page open in front of him. The answer is accurate, it is up to date, and if you built it well, it can even point back to which page it came from, just like a good student citing the source. Let us replay the whole journey one last time, fast. So it locks in, you asked a question, it became an embedding. The vector database used that embedding to retrieve the closest pages. Those pages became the context and question were packed into prompt. The LLM read the prompt and produced a grounded answer. Closed book guessing became open book answering. That is RAG. Common misconceptions. Before we wrap up, let me clear 4 common misunderstandings because these confuse a lot of beginners. Misconception 1. RAG makes and the AI smarter, retrains it, right? No. RAG does not change the AI's brain at all. The student is the same. We simply hand him the right book at the right time. Nothing is retrained. Misconception 2. Embeddings are the answer. No. Embeddings are just meaning coordinates used for searching. They help find the right pages. They do not write anything. Misconception 3. The vector database understands the answers questions. No. The vector database only fetches the closest pages. It does not think or answer. Only the LLM writes the answer. Misconception 4. With RAG, hallucinations are completely impossible. Not quite. RAG greatly reduces hallucinations, but if you retrieve the wrong pages or the answer simply is not in your documents, the AI can still slip. Good context in means good answers out. Garbage in, garbage out, even for open book students. Recap and closing. Alright friends, let us bring it all together. A plain AI is a closed book student working from frozen general fuzzy memory, and it guesses confidently when it hits a gap. Those confident wrong guesses are hallucinations. RAG turns that closed book student into an open book student. We convert every page into meaning coordinates called embeddings. Store them in a meaningful organized library called a vector database. Retrieve the few most relevant pages for each question. Place them on the desk as context. Bundle everything into a clear prompt and let the LLM write the grounded answer. Question, embedding, vector database, retrieval, context, prompt, answer. 7 boxes. One simple idea, give the student the book. This is basic RAG and you understood it without a single line of code. Thank you.